Hi everyone, welcome to Mernda Central Science Labs. I'm Marcus.
And I'm Betty.
And we're your
Lab techs.
Okay, so today's topic is acid-base indicators. And to start off with, we're just going to do a bit of a quick recap, a very simple recap on what acid and bases are. Alright, so an acid is a hydrogen atom that has lost an electron, so it becomes positive. So you've got a H plus ion, so a hydrogen ion. And the more hydrogen ions you get, the more acid a solution is. On the other side, you have something called an OH ion. And so this is what they call a hydroxide ion. And the more of these hydroxide ions you have, the more basic a solution is. So what happens when they come into the middle? Now what you might notice is one hydrogen, there's an oxygen and a hydrogen. Now if we have two hydrogens and an oxygen, what do we get in the middle? We get water. And water is neutral. A water molecule is the basis of pH. If you actually remove one of the hydrogen ions, or hydrogen atoms, it becomes positively charged, and what's left over here is a OH ion, or an oxygen and a hydrogen atom connected together, and it becomes negatively charged. To make it really, really simple, an acid is something that has lots of hydrogen ions and not much hydroxide ions. A base is something that has lots of hydroxide ions and not many hydrogen ions. And if you combine the two together in the middle, so if you actually neutralise, or what they call neutralisation, if you put the equal amounts of hydroxide and hydrogen ions together, you end up with water which is neutral, which is why you can neutralise acids. So these are the base, this is the acid side, and this is the base side, and this is the neutral. So that is the basic explanation of what acid and bases are. Now, so what is an acid-base indicator? An acid-base indicator is a chemical that changes colour when it gets to a certain concentration of acid or a certain concentration of base, or if it's neutral. Now, we've got the ones we're going to be using today. We've got a red cabbage indicator which we're actually going to make out of cabbage. We'll show you how to do that later. We've got phenolphthalein, which is actually a base indicator, so it actually indicates when a solution gets to a certain level of alkalinity or becomes a base. We have methyl orange, which is an acid indicator, which tells you when a solution is getting towards an acid solution. And then we've got universal indicator, which is actually one that can give you an indication of all the different pHs from very, very acid to very, very basic. Alright, so the purpose of our experiment today is to try to understand what pH is, firstly, and then to look at a range of different indicators. We actually have 4 that we're going to look at today, and understand what pH they change at, what colours they change to, and how these colour changes could be used in other experiments. Materials for today's experiment. Well, firstly we start off with our safety gear, of course, safety glasses, gloves and lab coat, because we're going to be handling acids and bases, and acids and bases can seriously burn your skin and damage your eyes, so you have to be safe. Other than that, we're going to be working with various equipment that you may or may not have seen before. The first piece of equipment we're going to be using are burettes. Now, burettes are long devices for measuring liquids very, very accurately. Now, if you do chemistry in later years, you'll actually be using burettes quite a bit. And for our burettes today, we've filled one with hydrochloric acid, which is an acid obviously, and one with sodium hydroxide, which is a base. And we're going to be using that for showing various properties of the indicators in a little bit. Other than that, we're going to be using 4 main indicators. We're going to make an indicator out of red cabbage, which contains anthocyanin, which makes sort of almost like a universal indicator. We've got phenolphthalein, which actually detects basic solutions and turns a lovely pink-red colour. We've got methyl orange, which goes from blood red to orangey yellow in acid solutions. And then of course, we've got universal indicator, which has a huge range of colours across all the pHs. Some other chemicals we're going to be using in this experiment. We're going to need something called sodium carbonate, which is a basic solution, which is going to be used for something called a Rainbow Fizz experiment, which is quite an interesting experiment. Of course, we're going to need our hydrochloric acid solution to refill our burettes. We're going to need our sodium hydroxide solution to fill our other burette. we're going to need various other glassware. So we're going to need our conical flasks. We may need some beakers to make the red cabbage indicator up. We're going to need some small pipettes to apply our indicator solution. For the first part of our experiment, we're going to test two of our indicators. We're going to test phenolphthalein, which is a basic indicator or a base indicator, which changes at around 8.2, a pH of 8.2 to 10. And we're going to test a acid indicator, which is methyl orange, which changes at about 3.1 to 4.4 pH. And we're going to do that by using our burettes to let the either a sodium hydroxide solution, a base solution, in slowly, or an acid solution in slowly. So we're going to add our phenolphthalein solution to our conical flask of distilled water, and we should get the liquid staying clear, because this is actually an indicator that changes at about 8.2 pH, and the distilled water should be close enough to around 7 or 8 at most. Very slowly add sodium hydroxide to the phenolphthalein, and we're going to stir it. And you might have noticed it went pink for a short while and it's gone back to clear. And that's because phenolphthalein will only change once the pH gets to at least 8.2. So we continue to add very small amounts. It's staying pink a little bit longer. And in later chemistry, this becomes really important because the amount you add can tell you exactly how much of a chemical reaction has happened or how far the chemical reaction has happened. So we'll continue to add the phenolphthalein. So I've moved down to the phenolphthalein again. We'll add a few more drops. And this time the indicator has changed to a ruby pink colour, meaning that the endpoint has been reached. Alright, so what we're going to do now is we're going to test the pH using an electronic pH meter, which is actually reading at about 8 for distilled water at the moment. And we're going to put the solution we've just tested with phenolphthalein into a beaker. And we're going to put the pH meter in and see what it reads. I don't know if you can see that or not. It's reading a pH of about 10.2. Now phenolphthalein changes to a full pink colour at 10, so that's showing it's actually quite accurate. It's actually changed at the pH that we were expecting. Alright, so our second indicator, which is methyl orange, is an acid indicator. It changes at around 4.4 to 3.2 pH. It starts off in a bright orange colour at neutral, and as we add acid to it, it should change to a nice ruby red colour. We're going to test the methyl orange by adding hydrochloric acid very slowly using our burette, and very carefully, if we zoom down onto the conical flask now, we'll add small amounts of hydrochloric acid, and you'll notice again, as we do that, you get a little bit of red forming in the solution, which shows that the indicator is changing when it first hits when the acid first hits the indicator. Add a little bit more. It's still going back to an orangey colour, so it hasn't reached the end point yet. Add a little bit more. You can see that red forming. Add a little bit more, and you can now see the colour has changed to a ruby red colour. So as we did before, we're going to test the methyl orange that we've just tested with our indicator to see whether the pH corresponds with what the indicator should say it is. So we'll pour the methyl red solution into a beaker. We'll get our pH meter, which is reading about 7.6 in distilled water, and we'll place it into the solution. We'll give it a swirl around. And we might have gone a little bit past our endpoint, but you can probably see there, it's reading about 2.9 in this solution, which is a little bit lower than what the expected 3.2 is, but not far. So we went a little bit past the endpoint. Now the important thing to remember about indicators is that they are actually fully reversible. So we have in the phenolphthalein solution here, we added a base, we added sodium hydroxide to make it become basic and turn pink. Now if we added acid to that, we know that when we add hydrogen ions or acid ions to hydroxide ions, they become water, become neutral. So if we add hydrochloric acid to the phenolphthalein solution, let's do it very gradually, magically it reverses and the pink colour disappears again, which tells us that the solution has become more neutral again. And similarly with methyl orange, which was the acid indicator, we added hydrochloric acid to get it to turn to the ruby sort of reddish colour. And if we put it back into the other side here and put hydroxide ions in the form of sodium hydroxide, it will then turn back to the yellow colour as well, showing that the indicator is fully reversible and that it has become more basic, has gone back towards neutral and has turned back to the yellowy orange colour. Okay, so the next two indicators we're going to test with our burettes here are universal indicator and red cabbage dye indicator. Now red cabbage contains a chemical called anthocyanin, and anthocyanin will change colour to various colours at different pHs. To prepare the indicator, we get a piece of red cabbage, we chop it nice and finely, and we then place it into a beaker, pour boiling water over it until it just covers the cabbage. The hot water will extract the anthocyanins, and once it's cooled we'll be able to then drain off the liquid and use it as our AcidBase indicator. So we'll pour a bit of the red cabbage dye indicator that we showed you, how Betty showed you how to prepare earlier, and we'll just decant off some of the solution. So we've got a nice bit of the indicator there, nice purple colour. And we'll put a bit of the universal indicator into some distilled water over here. What we're going to do, we're going to acidify both of these solutions to start off with. So we'll go over here and we'll place a fair bit of acid into the solution. And we'll give it a swirl. You can see it changing to a nice sort of maroony colour. We'll go a little bit more. I think that's about as much colour change we'll get with the red cabbage indicator. And we'll do the same. So we'll just put those two together so we know they're together. And we'll do the same with the universal indicator. We'll give it a swirl and it goes to a nice pink-red colour. So, and what we're going to do now is we're going to get each of them and we'll show you through the colour range as we add more and more sodium hydroxide. Okay, so the universal indicator, as you can see now, is nice and red, so it's around pH 0 or maybe pH 0 to 1. And what we're going to do is we're going to try change it through its colour range by adding a slightly weaker solution of sodium hydroxide than we did previously, because it was changing way too quickly. So we'll add a few drops at a time. Shows how accurate these pH indicators can be, because they can be changed by a single drop. Give it a good swirl, and you can now see we're definitely getting into the green stage, or the green part of the spectrum. You can see now that the green is now becoming closer to the 7-8 sort of range. Now if we continue on, you can see it's getting quite blue now. Later on we'll do another experiment which actually shows this much more clearly, and we just put a whole lot more in now. So you can now see it's going into a much bluer colour. If we add enough sodium hydroxide, there you go, it's starting to go into very dark blue. So that was the full colour range for universal indicator. Alright, so our second indicator was the red cabbage indicator. Now we've acidified this solution with some hydrochloric acid already, so it's a nice bright sort of red colour. We'll put it under our burette with the 0.5 molar sodium hydroxide, so we could add hydroxide ions in there to slowly make it more and more basic. So we'll add a little bit of sodium hydroxide and we'll see what colour changes we observe. So we've gone from ruby red. Alright, so it's going to a sort of a more cherry sort of pinkish red now. And if we add more still, we'll go to our final, well, we went through a bit of a purple colour for a second there, which we saw. And eventually it turns into a nice dark blue colour when we get up to pH of about 11 or thereabouts. Okay, so a really fun, interesting experiment to demonstrate the range of colours you get from universal indicator, and we're going to try it on red cabbage indicator as well, is the Rainbow Fizz experiment. Now the Rainbow Fizz experiment, we actually get a couple of test tubes. We're going to have one for red cabbage on this side, one for universal indicator on this side. What we do, we fill the test tube up with 0.5 molar hydrochloric acid, so nice and acidic. We go to about 2 3/4 full on each tube. We're going to add the indicator to each tube, so we'll add a few drops of universal indicator to the top of this one, and you'll see that the top turns nice and red. And we'll add a few drops of, or a bit more because it's not as concentrated, red cabbage indicator to the top of this one, and it'll turn nice and pink. Okay, so we've got the two indicators in the solution. What we're going to do now is we've got sodium carbonate solution. Now sodium carbonate is very basic, whereas the hydrochloric acid is very acidic. So you'd expect the two of them to react to start forming bubbles of gas and also to produce water and neutralise the solution. So what we're going to do, and sodium carbonate, because it's quite concentrated, is also very, very heavy. So if we put it down the side of the test tube, it will go to the very bottom of the test tube without mixing too much with the top solution of acid. So we'll put it down the side of the test tube very slowly. And we'll keep adding and keep adding and keep adding. That will probably do for the moment. And if you watch it really, really carefully, so if we zoom on this test tube over here, and if you watch it very, very carefully, I'll just grab the universal indicator chart. What you'll notice is that the sodium carbonate, which has gone to the bottom, which is very, very basic, is showing a pH of about probably 11 or 12. And as you go up, the sodium carbonate actually reacts with the hydrochloric acid and neutralises it until you get to a place which is green, about that level there, which is saying it's neutral. Then you go into the yellow zone, which is actually where you start getting to pH 3, which is becoming more acidic, until you get to the very, very top, which is quite red, which is showing that the top of the solution is still acidic, or still hydrochloric acid and very acidic. But it's a very neat way to show the same sort of colour chart, if you like, in a test tube. Alright, so we're going to now try the red cabbage indicator that we made earlier and see how it reacts to the Rainbow Fizz experiment. So on our test tube over here, we're going to very carefully get our sodium carbonate again, down the side of the test tube, very, very slowly add our sodium carbonate down the side of the test tube, which is heavier than the acid, so it tends to go to the very, very, very bottom. And we'll watch and see what happens. Now, with the red cabbage indicator, there wasn't as many different colours involved with the colour change, but you can actually see quite clearly three colours. You go, the anthocyanin, which is the chemical that's in the indicator, goes from blue to a violet colour in the middle to a pink colour at the top. Blue at the bottom where it is still basic with the sodium carbonate, then it's purple where it becomes neutral where the acid mixes with the sodium carbonate, and then it's finally red where the acid still is unchanged. So what have we learnt today in today's experiment? We've learnt that acids and bases are basically water when it splits into two halves. That one half is a hydrogen atom on its own, which is positively charged, which is called a proton, which makes this a solution acid. The other half is an OH ion, or an oxygen and a hydrogen joined together, which is negatively charged, and when there's lots of that, it makes a base. And when the two come back together in equal proportions, you end up with H2O, which is water, which is neutral. Now, the second thing we've learned is about different sorts of indicators. We looked at phenolphthalein, which is a base indicator. We looked at methyl orange, which is an acid indicator. We also looked at universal indicator, which is both an indicator through all the whole pH range from 0 to 14. We also made our own indicator out of red cabbage, which also acts as a universal indicator from low pH to high pH. So, and we know that indicators are chemicals that change colour at a certain pH. So we know that the pH which they change colour, so they can be used for doing chemical analysis. So in later years when you do chemistry, chemical analysis will become part of what you're doing in class. So you get a whole range of different colours forming. We won't go through all the different indicators again now, we've already done that. And we can do something called a Rainbow Fizz experiment where we can demonstrate the range of colours that an indicator can form. So this is universal indicator, going from the purpley blues through the yellows, orange, pink, and then to red. So from the base solution to the acid solution at the top. We also tried the same thing with our red cabbage indicator, and we found that it could do a similar sort of experiment where we got the blue at the bottom for the base, pale purple in the middle for the neutral solution, and a pinky colour at the top for the acid solution. So So I hope you've enjoyed today's experiment. I hope you've learned a little bit about indicators, and in coming years in chemistry you're going to do an awful lot more with them and have a great deal of fun. Alright guys, that's it from Mernda Central Science Labs for now. Bye from me, Marcus.
And bye from me, Betty.